Hello class, this is a video tutorial on present value tables. Recall how future value tables simplify the recurrence relation or the annuity tables calculations of annuities. So in this annuity, it's 5% per annum. The regular deposit is $2,000 for each year. Now we've seen this sort of table multiple times now. And we saw how the future value table just finds the factor of 5% and 4, and we multiply that factor by the regular deposit to get the exact same or very close to the recurrence relation calculation. Now let's think about what this annuity represents. It's a repeating deposit of $2,000 every single year. But what if the person wanted the same end future value, so they definitely want this amount, but wanted to do a single deposit instead of an annuity? How much would they need? So, emphasizing again, instead of 4 different deposits of $2,000 at 4 different years, what single deposit will give me the same result on these same investment details? Well, this can actually be calculated using just the regular FV formula or the compound interest formula. So take a look. Since we want the future value or the annuity to be this, we let FV 8620.20, PV is the present value, and that represents a single deposit. So this I'm just going to put as P. The rate in this particular problem is 5%. I'm going to let that be 0.05, and N is 4. Now take a look. We can solve to find the single deposit. P bracket 1 plus R, which is 0.05, so 1.05 to the power of 4 will give us this future value of 8620.20. Now we can find P, that single deposit, by dividing both sides by that number here. Dividing both sides by that number, we'll cancel out these two, leaving us with P on its own, and we just type this into our calculator. Okay, so 8620.20 divide brackets 1.05 to the power of 4. This gives us $7,691.86. So the present value of this annuity, if it were just a single compound interest formula application, would need this amount. And just to show you, if we were to run this number back in, FV equals 7091.86 times 1.05 to the power of 4. 7091.86, 1.05 to the power of 4. And as you can see, it gets us very, very, very close to the future value of the annuity. So a present value of an annuity is the single deposit that matches the repeating deposit of the annuity. Well, enough talk. This is what a present value table it does. It is used to calculate the single deposit or the present value that gives the same final future value of an annuity of the same rate and time. Okay, so let's go 2 examples to demonstrate what we mean. So use this present value table. Notice how it literally says present value. You need to be mindful of that when doing these types of questions. Let's find the present value of the following investment annuities. So in this case, $9,600 per year. This is the annuity. 4% per annum for 3 years. So 4%, 3 years. There it is, 2.78. Once we have that factor, 2.78, we still multiply it by the repeating deposit times 9,600, 26688. So this is the single deposit that will get the same end result as this annuity. Let's do this another one here. It says compound 10% per annum, compounding yearly for 2 years, and we're going to be depositing $900 each year. Now I want you to imagine, before we continue, how this annuity can be calculated as the table or just as the future value table, and the end result that gets you. But that is a repeating deposit of this amount. Well, now that we have this value, we simply go 1.74 times the recurring deposit. So 1.74 times 900. The present value, or the single deposit, is 1566. And so that is what the present value table does. Let's cut the video short here. I'll leave these last two examples on the next set of videos. Hope to see you then, and best of luck.